Hi, my name is Al Reynolds. I've been asked by Developmental Cell to present a paper that was selected by Zena Werb. And I think the significance of the paper, in part, is that this is the first example of a p120 knockout in mice in vivo. So here's the title of the paper. The work was done by Michael Davis, who you see here on the left, and Renee Ayrton. p120 does a lot of things. But the main thing is, or the most striking thing, is it binds to the cytoplasmic domain of E-cadherin and stabilizes it. Not just E-cadherin, but the entire cadherin complex. This turns out to be true for all members of the classical cadherin family. That is 26 members found in almost all tissues. In most epithelial cells, if you knock down or knock out p120, you have a substantial downregulation of E-cadherin. So that's just to illustrate quickly. The first example, this was Renee's paper, was in SW48 cells, which sort of lack of functional p120. This dramatic rescue of the epithelial phenotype when you add p120 back. Michael followed that up with shRNA about a year later, and here you see the same thing. If you knock down p120, biochemically, you lose the majority of E-cadherin, and alpha and beta-catenin go with it. Now, if you look at the paper, you might wonder why we chose to knock down the salivary gland. And of course, actually, we didn't. We were trying to knock it out in the mammary gland. This is one of the first, my lab's first lessons in transgenic mouse technology. All of the mice died at birth. So Michael would have to get there at 5 in the morning and rescue the mice before they started to suckle, where they would die within a couple of hours. So he had spent about 3 years making the animal. It got germline. We were pretty excited about it, but he didn't have another 3 years to create another model. It turns out that the salivary gland is not only a classic model for branching morphogenesis, it also begins development at embryonic day 11, well before birth, and is completed by the time the animal is born. So we looked at the salivary gland, and it worked out beautifully. So here you see the phenotype at day 1. And of course, we have to look at it. That's the last time we can look at it, because none of the mice actually make it till day 2. So the expression of p120, here's the entire gland. Below that, you see the knockout. The knockout is pretty good. It's almost 100%. And then next to it, you can see the knockout phenotype. I'll come back to that in a minute. To evaluate the phenotype, we first went ahead and did a time course. Here you see it. The development is pretty much the same at age embryonic day 13, 15, 14, and 15. And then pretty much all hell breaks loose. When the acini start to develop at embryonic day 17, you see this major difference instantly, because the acini simply don't form in the absence of p120, which is a complete surprise to us. The other thing we noticed that was unusual is that the epithelium, you see on the top, the normal sort of bilayer, 2 layers of cells, 2 layers of nuclei. And you see that this highly irregular epithelium, which according to our pathologist, Kay Washington, closely resembles a phenotype called intraepithelial neoplasia. So if you look over to the right where we've stained the gland, this is a little misleading because it's stained for sodium potassium ATPase. And we do that because it's all p120 negative. What you can see is that the gland holds together pretty well, surprisingly well. What you see is this sort of breakthrough where the cells just lose polarity. You see these sort of ruptures into the lumen. And so the wall is pretty weak, and the structure can't be maintained if p120 is not there. This second to last slide was a little bit disappointing in that when we looked at it under the scope, a fairly common effect to see E-cadherin downregulated by about 50%. And it's pretty clear when that happens that what's going on is there's a p120 family member like RBCF or delta-catenin. That is, there's enough of it there to partially rescue E-cadherin. What's not so clear is what that means, because the amount of E-cadherin doesn't really correlate very well with the phenotype. But to give you an example of how variable and extreme it can be in the other direction, here's an example in the prostate, another mosaic gland, where you see p120 expression on the left, p120 knockout on the right side of the gland. And what you see is that E-cadherin is downregulated almost entirely. Beta-catenin is downregulated as well. There's no other cadherin backing this up. And in the prostate, there's no effect at all. This is the first example of p120 knockout in an animal. And the phenotype was striking, similar probably to what would happen in the mammary gland. And it was a nice validation of what we'd seen already in vitro.